I am Professor José Bezerra Menezes Filho, and I live in Brazil. And I want to show you a lecture about a single wave sinusoidal surge feeding a resistor. Why I am speaking English? Because I want to connect it with the peoples around the world. It is very important to to the world to know a little about the Brazil. Brazil is no not is not very known around the world. It's there is exist uh, several types of vision about Brazil. Sometimes the foreign people think Brazil as a carnival country, only carnival country, and I want to connect it, and if possible, to establish a connection, a conversation with people around the world. Okay? Enjoy the video.
Let's talk about a single resistor fed by a power supply with a sinusoidal wave. And, okay, let's go on view the waveform. Here we can see the sine wave of voltage and we can see the sine wave of current. Let's gonna view better. Okay, okay, okay. Um, corrente. Okay, okay. Point view, manual limits. Let's gonna put 6 maximum of 6 in the current wave and -6. Okay, this is the waveform of the current in blue, and this is the waveform of voltage in black. We have a frequency of 6 Hz and the value, the maximum value, the peak value of the voltage is 311.126, etc. Okay, let's go with our presentation. The voltage and current, the mathematical formula of the voltage is shown here. We have a sine wave where we have the maximum value of this voltage and the maximum value of the current. We have the sine of 2pt above the period capital T, and the same waveform of current. The frequency, as I said, is 60 Hz. The maximum of voltage, and we put the resistor equal to 100 ohms. If you calculate the power, we have power in function of T is Vt multiplied by Et. If we put the mathematical formula of the voltage here and the mathematical formula of the current here, we have this expression, okay? Vp square Vp above R square sine of 2pt above capital T. Okay, let's gonna view our power. Okay, this is in red. We have the power. Okay, we have 1 kilowatt maximum of the graph of the draw, and we can see that the power never is below the zero. During all time, the power go from power source to load. We can see that the power never go from load to source. Okay? Well, we have the expression of Pt, that is function of the square sign. Let's eliminate the square using the well-known formula of the cosine. Cosine of two angles, the summation of two angles A and B, is cosine of A multiplied the cosine of B minus sine of A multiplied by sine of B. Cosine of A minus B is cosine of A, cosine of B, plus sine of A, sine of B. So if we put A equal to B, we have cosine of 0, A minus A equal 0. Okay, we put this formula is square cosine of A plus square cosine of square sine of A. So cosine of 0 is equal to 1. 1 is cosine, square cosine of A, square cosine of A plus square sine of A. And so if you combine this expression with this another expression, we have this expression, this formula, 2 multiplied by square sine of A, it's equal to 1 minus cosine of double A. So square sine of A is equal to half multiplied by 1 minus cosine of double A. Okay? So if we put A, if we put A equal to 2pt above capital T in this expression, we have the power, the instantaneous power of the circuit is equal to this expression. It's important to note that the period is a half of the former period. So the frequency of the power signal is twice the frequency of voltage signal. Okay? So let's view the average power of signal. The average power of signal is obtained by the integral. The integral of the power, instantaneous power, if we divide it by T, capital T, okay, capital T, we have this expression, okay? Vp, square Vp above R, capital R, multiplied by 1 above capital T, multiplied by integral of square sine of 2pt above capital T, multiplied by dt. Let's substitute this expression for our expression in function of the cosine. Okay? We have so the expression of average power of the circuit. If we continue to resolve according to the well-known integration formula, we have finally this value. Pm, the average power of our circuit, is equal to square Vp above to capital R. Square Vp is equal to Vp multiplied Vp. The number 2 is square 2 multiplied by square 2. Square 2 multiplied by square 2, it's equal to 2. Okay? Oh, excuse me. So, if we have a CC circuit, the power is VCC, the continuous voltage multiplied by continuous current. This is continuous current, it's equal to VCC divided by capital R. So we have this expression for CC circuit. If we put this expression equal to our previous expression, VCC multiplied by VCC above R, it's equal to Vp above square 2 multiplied by Vp above square 2 multiplied by R. So, in order to substitute this circuit for AC circuit, we have VCC, it's equal to Vp above square 2, and we call this expression RMS value of V, and we call this expression, okay, it's separated. R is separated by square 2. It's called IRM, current put in square. Okay, so let's put another circuit, voltage. Okay, let's put a ground. Okay, if we have the value 220 and the same resistor, okay, 150 ohms. Let's join. Okay. 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 This is CC circuit, and this is AC circuit. The resistor, the resistance is the same. Okay, and this source is the RMS of this source. Let's gonna view the results. First, let's gonna view the power, instantaneous power of this circuit. Let's gonna view the instantaneous power of this circuit. It's important to note that the blue line is the power, instantaneous power of these circuits. It's the average of the power, instantaneous power of the AC circuit. Okay, so if we calculate the average power of this wave, it's equal to this value. Okay. So thank you for your assistance, and bye bye.